All right, class, it's time to start Chapter 7. Chapter 7 is all about correlation and causality. In Section 7.1, we're going to be talking about finding correlation and what that means. Here are our learning objectives. So correlation exists between two variables when higher values of one variable consistently, that's the keyword, consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another variable. So for example, there is a correlation between the variables height and weight, right? The taller someone is, we can assume it's correct that the more they would weigh. There's also correlation between the demand for computers and the prices of computers, right? The less the demand, the more the price increases, right? That way they can continue to make money even though they're selling less. There's also correlation between practice time and skill among piano players, and that makes sense. That is that those who practice more tend to be more skilled. One of my favorite examples actually of correlation is the fact that the number of broken arms in kids increases with the number of ice cream sales. So keep this example in mind as we go forward, but the number of broken arms increases as ice cream sales increase. Why might that be? Well, let's keep thinking about it. So a scatter plot is a graph in which paired sample data are plotted as points, i.e. coordinate points, with one variable, our horizontal axis being our x, and our vertical axis being our y. X is our independent variable, right? It's independent. We also can call this our explanatory variable, and we plot that on our horizontal axis. Y is our dependent variable. That's our response variable. It depends on X, and that's where we're going to plot on our vertical axis. So how do we create a scatter plot for weight and price of diamonds? Do we expect the price to depend on weight? Well, yeah. So that would make our weight, you can't really see that color, sorry. Weight is going to be our explanatory variable, so our x, and price is going to be our y. So here's all the data for prices and characteristics of diamonds. So let's go ahead and take a look. So here's our scatter plot of the price of diamonds, and it looks like it does have a positive correlation. Ooh, I haven't talked about that yet. Okay, so it does look like it kind of forms a line. This is an example of positive correlation. Positive correlations are when the values of y tend to increase with increasing values of x. Correlation becomes stronger as we go from example A to example C because our examples, our points get closer and closer to being a line, right? They get closer and closer to what our line might be. And C is an example of a perfect correlation in which all the points fall along a straight line. Negative correlation are when the values of y tend to decrease with the increasing values of x. Again, our correlation becomes stronger as we proceed from example D to F, and F shows a perfect negative correlation. Everything falls in one straight line. We can also have no correlation, right? There's like no line that these points are closest to. That means our values of x aren't appeared to be linked to values of y in any way. And we can have a nonlinear relationship. So where x and y appear to be related, but the relationship doesn't correspond to a straight line, right? This is not a straight line. That's a parabola. Flashback to college algebra, sorry there. So let's look at the three different types of correlation, right? We said positive, negative, no correlation, Oops, there's a fourth one, nonlinear correlation. Next, we're going to talk about measuring the strength of a correlation. So statisticians measure the strength of a correlation with a number called the correlation coefficient. We're going to represent this with the letter R. The correlation coefficient is a measure of the strength of a correlation, and its value can only range from -1 to +1, right? -1 would be perfect negative correlation, +1 would be perfect positive correlation. If there's no correlation, the points do not follow any ascending or descending straight line or pattern, and the value of R is close to 0. 0 tells us no correlation. So values of R close to 1 mean a strong positive correlation, and positive values closer to 0 mean a weak positive correlation. So you want to be as close to 1 as possible to have the strongest correlation. Values of R close to -1 mean that we have a strong negative correlation, and negative values closer to 0 mean we have weak negative correlation. So if there's positive correlation, our correlation coefficient is between 0 and 1. Both variables increase together, right? It looks like it's got positive slope. And a perfect positive correlation in which all points on a scatter diagram lie on an ascending straight line has correlation coefficient R equals 1. I want you to note that perfect correlation, positive or negative, doesn't occur in the real world. It might in some of the examples in our text, but it's not going to happen in the real world. If there is negative correlation, the correlation coefficient is between -1 and 0, but it's not equal to 0. If it was equal to 0, there'd be no correlation. And when one variable increases, the other decreases. So we've got something that looks like it has negative slope going downhill. And if all the points line up perfectly on a descending straight line, it has correlation coefficient R equals -1. Ooh, that's a mouthful. Correlation coefficient. So let's take a look at this example showing scatter diagrams for the number of farms and mean farm size in the United States. So each dot represents data from a single year between 1950 and 2010. And the years are on the earlier years are on the right and the later years on the left, right? So the number of farms has been decreasing over time. Let's go ahead and estimate the correlation. So if I was going to draw a line that I thought would be closest to all those points, right, it's definitely going to be negative. Is that weak? No. Is it perfect? No. So maybe something like 0.9 or 0.8, 0.9 or 0.8. I really just want you to estimate.